Okay guys, so welcome back again to another video. In this video we are going to talk about this simple distillation technique, right? This is a very simple concept. It's not a big deal. Let's look into this amazing technique, right? First of all, let's talk about this distillation. So we take a new page, right? Now when it comes to distillation, okay, basically what we are talking about is a separation. Okay, now let's say you have a solution. This contains A, B, C. Likewise, there are reagents. You have to separate these guys. So as a separation technique, you can use this distillation process. So this distillation process mainly involves in the boiling point. The technique is based, this separation is based on your boiling points, or the how can you say, the difference between each component's boiling point is the main factor which we are using in this distillation process. We have several kinds of distillations, but mainly there are three which are more popular. The first one is the simple distillation. And the second one is the fractional distillation. And the third one is the steam distillation. There are others, right? But we will more focus on these three. Now, when it comes to exams, right, you need to understand in what cases you use this each distillation process. You cannot use this all three for every process, right? Each process has its own advantages and disadvantages, right? So what we gonna do is we are going to choose specific processes and we are going to stick with one particular technique. As an example, let's talk about the simple distillation. Okay, in order to use the simple distillation, you must have a considerable amount of difference between the boiling points. Let's say this is your solution. This solution contains A and B. The A has a low boiling point and B has a huge boiling point, right? Best example is the well water. Okay, now the well water contains minerals, salts. Likewise, these guys having a very huge boiling point, right? And the other component is the water having 100 Celsius of boiling point. So you can use the simple distillation and heat your solvents up to like 100 Celsius. So you can separate water from this very high boiling point, the component containing very these component containing very high boiling points such as minerals and salts. Likewise, the simple distillation you can only use when you have a considerable amount of difference between your boiling points in the reagents. Now, the fraction distillation, you can close this particular error. You can use normal differences, like let's say you have a component which having the boiling point of 50 Celsius and you have B which has boiling point of 80 Celsius. You can use fractional distillation to separate these things. And the other thing is you can use several components. You can use several components to separate at one time. The best example is the extraction of, like, the separation of oil. So you know how we can obtain the petrol, right? Let me quickly sketch it out. So you can use this huge column, and likewise each part contains different of heat, like 100, 200, likewise. So each compound can be extracted from each column. So we will talk about this in a separate video, right? I just wanted to give you the simple idea. And finally, the steam distillation is mainly used for organic purposes, like when it comes to the organic compounds, they can be destroyed in very heat. So what we are going to do is we are going to use steam as a heating source. So we will talk about these two, fractional distillation and steam distillation, in separate videos. Let's talk about the simple distillation, how we can do it, what's the concept behind it. So this is the basic apparatus which we are using for simple distillation. Okay, now this is round bottom flask. Here you are putting your solution here and you're going to heat it up. Now when you heat the solution, this will boil up and the vapor will be go through here. Here you have sealed this part of entrance and you have attached a thermometer. Or sometimes let's say you need to do a reaction and extract the products of it, then you can use another apparatus to slowly add the particular solvent into your reaction mixture and then let it out, let the vapor out. Now this is called the Liebig condenser. Okay. This is called the Liebig condenser. You can see there's a tube inside like this. This tube, right? This tube is going to carry this incoming vapor through this part. Now these are two entrances which we can input water from here, water input and water output. So what will happen is this water will go through this tube, like not in this inner tube, right? This water will go around this tube which will cool this tube. So when the heated vapor is going through our tube, this water will cool it down and convert it into a liquid. Now that liquid parts will go through here and extract it into our external compartment here. You can use a flask for it. Okay, now there are several points you need to be very aware of when it comes to the simple distillation. When you are doing it practically, you may find out it's not that simple, right? First of all, this angle, if you use direct like this, it won't work, right? You have to extract the liquid, so your vapor will be, vapor can convert into the liquid like in this part or this part, right? So you need to take it into your container here. So in order to do that, you need to have this angle. So beware of that. When you set the apparatus, there should be a considerable angle in order to pull out your extracted solvent. And the other thing is you need to seal off these edges, especially these joints. So you can use things like grease, like oils likewise. So you can use those guys to seal off these edges, otherwise your vapor will be leaked out. Then finally the yield will be lower. So such things must be considered when it comes to simple distillation. I hope it's fine for you now. Like again, I have told you in the beginning, like for what occasions we use this simple distillation, right? So in this case, let's say your solution is a well water, then your well water contains water. So we need to extract water, original like distilled water, let's say. We need to extract distilled water, like no minerals in it, but the well water contains minerals, salts, and maybe some harmful bacteria likewise. So what happens is these minerals are having very high boiling point, so they won't get vapored out. Only the water at 100 Celsius, they will vapor out. So this tube contains only water vapor. The tube will cool it down to convert back into the original water. Not original meaning like the pure water, right? So minerals will be stay here. This is the basic concept under the simple distillation. So you need to be very aware that how you can use it, right? If I tell you an example, let's say your question asks whether this kind of position, let's say you need to extract methanol from another mixture, let's say a C. So this C has a boiling point of, let's say, 150 Celsius. So it asks whether you can use simple distillation or other thing. So in this case, you can use a simple distillation, right? Because methanol is highly volatile compound, so you can easily use the simple distillation. You can maintain your temperature below 150, maybe even below 100 Celsius, then you can easily get the methanol vapor and convert back into the solution. Likewise, these are the applications. The simple distillation is pretty much easy. In next video, we will talk about the fractional distillations, and then we will move to the steam distillation. I hope it's fine for you. If you have any problems, feel free to ask me in your comment section. I will try my best to answer your questions.